In question 1, we've got the mixed number 2 1/6 divided by the fraction 8 over 9. So let's start by changing the mixed number into a top-heavy fraction. So 2 times 6 is 12, plus 1 is 13. So that fraction will be 13 over 6. We're going to change the divide 8 over 9 into a times by 9 over 8, because if you're dividing by a fraction, you want to multiply by the reciprocal, in other words, a fraction flipped. At this point, we could just now multiply the two numerators and the two denominators together, but the numbers are quite high here, and this is a non-calc paper, so you might want to simplify, which you can do by dividing both of these by 3. They're both divisible by 3, even though they're in different fractions. That's what I'm going to do, just to make it a little easier. So that would make this 13 over 6 divided by 3 is 2, times, instead of 9 over 8, I'm going to make that 3 over 8. Just to make the numeracy a little bit easier. So now we can multiply the two numerators to get 13 times 3, which is 39. The denominators 2 times 8 to give us 16. And we're just going to put this back as a mixed number. So 16 goes into 39. 2 times as a whole number, that would take us up to 32. So that leaves 7 left over. So it's going to be 2 and 7/16. Question number 2 is expand the brackets and simplify. This first bracket is all squared, so be careful that you don't just think that's going to be x squared plus 49, which is really tempting because a bracket squared, remember, means the bracket multiplied to itself. So unless you're very good at these and have had a lot of practice, it's good practice to write the bracket twice when you're squaring a bracket. Second bracket we need to multiply out. I'm just going to go ahead and do that now. So that's going to be 6x squared minus 60. Now we can properly multiply these two brackets together without missing any terms. So we're going to get an x squared, we would get a 7x, and then another 7x, and then a 49. If you don't write the bracket twice, it's very tempting to, like I say, just have this and this, and to miss these two middle terms. The end terms I'm just going to leave alone for this line of working, and then we just need to gather the terms all together. So we've got a 1x squared and a 6x squared, so that's going to give us a 7x squared. These two added together would give us 14x, so it's going to be plus 14x. And then we've got 49 minus 60, so that's going to go into the negatives. That's going to be negative 11. And that's the final answer for question 2. In question 3, we've been asked to solve the simultaneous equations or systems of equations. And we're going to use elimination of a variable to achieve that. So we need to start by matching up either the x's or the y's. Doesn't matter which one you choose, you'll get the same answer both ways. I think I'm going to choose to match up the y's. So that means I'm going to have to multiply equation number 1, if you like, by 2, because that's the opposite coefficient. And I'm going to multiply equation 2 by 3, because that's the opposite coefficient. Or you might multiply by a negative number. It's up to you. There's different ways to do these. Doesn't really matter though, as long as you get the number 6 or negative 6 in both of the equations. So remember to multiply everything by the number. So first equation, multiplying everything by 2. So that's going to become 4x plus 6y equals 16. Second one, we're multiplying by 3. Again, remember to multiply every term by 3. So that's going to become 15x plus 6y. And there I've got my two terms matched up. And again, it doesn't matter if you match them up as two positives or two negatives or one of each. And then the final term, minus 2 times 3 is negative 6. This is a point where these can go a little bit wrong because remember, these don't just automatically cancel. They only cancel if you correctly add or subtract the two equations. Because in my case, these are both positive, to get those to eliminate, in other words, to go to 0, I need to subtract my two equations. Essentially, I'm subtracting. Doesn't really matter if you subtract up the way or down the way, so I'm just going to go down the way. So 4x minus 15x, that's going to give me minus 11x. These two are going to eliminate, and then on the other side, I've got 16 minus 6, so it's going to be 16 plus 6, a double negative, go watch out for that. So that's going to end up being 22. And notice that these numbers, 22 and 11, do actually divide, so it's a good sign that we've done this correctly. Dividing both sides by negative 11, remember this is just a normal equation at this point. Dividing both sides by negative 11, we'll get x equals negative 2. So it's good practice, you know, sometimes to like label your equations 1 and 2 and explain what you're doing as you do the working, but I'm just going to go through the actual working part. So x equals minus 2. You'd maybe want to write a little explanation at this point, like substitute x equals minus 2 into one of your equations, I'm going to substitute back into the first equation. So the first equation says 2x plus 3y equals 8. Remember, you don't need to repeat the whole process for this, you just need to sub back into one equation to get the y value. So we now know that x is negative 2, so it's going to be 2 times negative 2 plus 3y equals 8. And then just solve in this like a normal linear equation. These two give minus 4 plus 3y equals 8. Add in 4 to both sides. 3y equals 12. And again, the fact that we're going to get numbers here that divide is a good sign. These don't have to come out to be whole numbers, but they generally do. They're generally designed that way, so it's a good sign that these are numbers that do actually divide. Dividing both sides by 3, and we get y equals 4. So the two solutions there are x equals negative 2 and y equals 4. In question 4, we've been given a graph of this parabola. We're told that the turning point is at 3, 2. We're also told that the equation of the parabola in completed square form looks like this. This is a generic equation. Of course, it needs a and b to be actual numerical values. And the first part of the question, part A, is to find those numerical values for a and b. Notice that that first part is just worded state. So state really means write down. In other words, there shouldn't be any working to find a and b. And that's because the turning point correlates directly to the completed square form. So just by looking at these, we should be able to figure out the a and the b values. And the a value in this case is to do with the x coordinate of the turning point. But because the x coordinate is positive 3, the a value needs to be minus 3. That's just the way that those correlate. You just need to know that as a fact. B, which is the outside number in the completed square form, that relates to the y coordinate of the turning point, but that number doesn't change. Slightly confusing that this one changes, that one doesn't, but the b value is just going to stay as positive 2. And if you think about it, if those values were in here, so in other words, if you had y equals x minus 3 all squared plus 2, you should be able to say, hey, if that's the completed square form, then the turning point is at positive 3 because that's a minus 3, and positive 2 because that's a positive 2. So we're essentially kind of doing that backwards. Instead of going from the equation to the turning point, we're going from the turning point back to the equation to get the a and the b values. Part B of the question is not worded state, which implies that there's a little bit of working to do. And in part B, we're trying to essentially find the coordinates of point P. So they've told us that point P has got coordinates 0, c, and the way the question is worded is to find the c value. But essentially that just means find the coordinates of point P. We've already got the x coordinate, so it's really only the y coordinate we're trying to find. That is what the c value is. Importantly though, we know this is a y-intercept point, and they've already told us that because it's a y-intercept point, it's got an x coordinate of 0. So what we need to do here, we need to take our equation, so we now know the equation as this, not just the generic form, so it's x minus 3 all squared plus 2, and we're just going to substitute the x value of that point, 0, into that equation and work out what we get for y. So we're anticipating a positive answer because you can see that this point P is in the positive part of the y-axis, and it should be a number above 2. This point's at 2 up the way, it should be something positive and above 2. So that gives us a little expectation. Putting in the 0, so 0 minus 3 all squared plus 2. 0 minus 3 is minus 3, so we can just make that a negative 3 all squared plus 2. Careful when you're squaring that because it is negative 3 all squared. So negative 3 all squared is negative 3 times negative 3, so it's going to be a positive 9 plus 2, and that comes out to be 11. And that seems reasonable because it's in the right part of the y-axis. So the full coordinates of point P, 0, 11, and that means in particular, in our question, the c value itself, which is what the question is ultimately asking for, the c value is 11. In question 5, we've been asked to determine the nature of the roots of this quadratic function. So it's just a straight up use of the discriminant. So let's start by identifying our a, b, and c values. So the a value, being careful with the signs for these, is positive 4, the b value is positive 6, and the c value, importantly, is negative 1. So be careful not to miss that negative. So we're just going to put these values into the discriminant, which remember is part of the quadratic formula, so b squared minus 4ac, and essentially just work out the numerical value that we get. So b squared, that's going to be 6 squared minus 4 times the a value, which is 4, times the c value, which is minus 1. 6 squared is 36. 4 times 4 times minus 1 is negative 16. There's already a negative there, so it'll be a double negative. So it's going to end up being a plus 16. Totaling those together, that will be 52. So remember, the numerical value itself doesn't matter, only whether it's positive or negative or 0. So in this case, we've got b squared minus 4ac has come out to be greater than 0. So in other words, a positive value. So that implies that there's two real roots, or you might write it as two real and distinct roots. So two real and distinct, or you could write two real and different roots. Two real and distinct roots. So that's the final answer, and you need that line of work in for question 5. Question 6 is a use of the cosine rule. Got to be slightly careful with this one though, because two things. One, it's in a non-calculator paper, so instead of giving you an angle, we've told you the result of the cosine of that angle, which can be a little confusing. Secondly, although it looks good in the sense of it being an ABC triangle, the cosine rule doesn't always line up with the actual ABC in the question. So in this case, we're being asked to find the length of A to B, which is, in our diagram, going to be small c, which is not what the cosine rule assumes you're looking for. It assumes you're looking for little a. We've actually already got little a, which is this side over here. So you can either amend your formula and keep the diagram, or probably better still, amend the diagram. And we can do that just by swapping that to be a, which makes this little a, and then we could just make this c, which would make this small c, and would make this small b. It's little a that we're trying to find. That would also mean that we need to change this from being the cosine of c to being the cosine of a. So we're just basically lining everything up to put into the formula. The way the formula is presented on the formula sheet is a squared equals b squared plus c squared minus 2bc cos a. Okay, so everything's lined up. We can just put the numbers in and then sort of crunch the numeracy. So the b value is 5, so it's going to be 5 squared, plus the c value is 6, so it's going to be 6 squared, minus 2 times 5 times 6 times the cosine of a, which is 1/5. Big temptation here is to write the cosine of 1/5, but we can't process the cosine of an angle like that non-calculator, so it can't be the cosine of 1/5, it can only be 1/5. Okay, like that. So the numeracy is still a little bit awkward, especially for this part, but if you notice that 5 times 1/5 would just give you 1, because it doesn't matter on the order in which you multiply these four things together. So a smart way to think of it is those two multiplying, and then those two multiplying, and then multiply those two numbers together. If you just multiply these straight across in the order which they're in, it's going to be more difficult. So 5 squared is 25, 6 squared is 36, 5 times 1/5, like I say, is 1. 1 times 2 times 6 is going to be 12, so it's going to be minus 12. Okay, so keep in mind as well that eventually we're going to have to square root this, and because it's a non-calculator question, we're hoping that the number we get in here is quite easily square rootable. Otherwise, something's gone wrong in the working. So this is going to be 25 plus, I'm just going to combine these two together first, that's going to give us 24. Adding those together, we get 49. Remember, at this point, that is still your a squared. So a is going to be the square root of 49, which is 7. This question was in meters, so remember your units. And remember just to maybe write your final answer, which was originally for the side AB. So maybe just write your final answer as AB equals 7 meters. In question 7, we've been asked to find the equation of the line of best fit for this scatter graph. So let's start by identifying 2 points, which I've put on the diagram here, labeling them up so that we can then find our gradient. So I'm going to label this one as x1, y1, and the second point as x2, y2. These are larger numbers, especially for the y coordinates, than you would usually expect. That means our gradient's probably going to be a bigger number than you would normally get for a straight line question. So just plug in those numbers carefully into our gradient formula. So let's start with the y2 minus y1. So it's going to be 50,000 minus the y1, which is 20,000. divided by x2 minus x1, which is 25 minus 5. So just crunching through the numbers, 50,000 minus 20,000 is 30,000. 25 minus 5 is 20. Could maybe just make the numeracy a little easier by knocking a 0 off both the numerator and denominator, just to take that down to 3,000 divided by 2, which is then going to give you a gradient of 1,500. Much higher than you would normally expect for a gradient, but it's just because of the y values being much bigger in this question. So in the context of this question, that 1,500 is fine. Notice also it's positive, and we expect a positive gradient because the line's going that way. So just plug in our numbers then into the straight line equation. So y minus b equals mx minus a, or y equals mx plus c if you use that equation. Either is fine. So I'm going to use this point here as my a and my b value. So y minus b, so it's y minus 20,000. So much higher numbers than you would normally see in the use in a formula like this, equals m, which is 1,500. Got to be careful not to lose zeros with these big numbers, bracket x minus the a value, which is 5. Then just expanding the bracket on the right hand side, that's going to give us 1,500x. 5 times 1,500, so 5 times 1,000 is 5,000, 5 times 500 is 2,500, so this is going to be 7,500. Just keeping the left hand side the same, so it's y minus 20,000, and then just going ahead to add the 20,000 to both sides to get it into the correct final form. So y is going to equal 1,500x plus 20,000 minus 7,500, that is 12,500. Just remember this question is not in x and y, it's in t and p. So the question was asked to write the equation using t and p, like in terms of p and t. So this is going to be p, because the p is playing the role of what would normally be the y, the vertical axis. And instead of an x, we're going to have a t. So it's 1,500 t plus 12,500. And that's the final answer for part A. Part B of the question is asking us to use that formula. So remember, it's the equation of a straight line, but it's also a formula that links together the t and the p values. And the context of this question is that the t value is a time value measured in years for how long an employee has worked for a certain company, and the time on the horizontal correlates to the salary, which is on the vertical. So in part B of the question, we're given a time value of 8 years, and we've got to work out the salary based on a time value of 8 years. So all we're really doing here is taking that 8 and plugging it into the formula. So it's going to be 1,500 times 8 plus 12,500. Slightly awkward numeracy again, so 8 times 1,000 is 8,000, 500 times 8 is 4,000, so together that's going to be 8,000 plus that 4,000 to give you 12,000. We're going to add that to the 12,500 just to get a final total of 24,500. And just remember that obviously this is in pounds, so monetary unit, so we're just putting in that final unit. And you might just want to write that somewhere separately to say something like the salary after 8 years is 24,000 pounds 500, 24,500 pounds. And that's the final answer for part B. In question 8, we've been asked to rationalise the fraction 12 over root 15. And we can achieve that just by multiplying the fraction by whatever root is on the denominator over itself. So we're multiplying by root 15, in this case, over root 15. We've now got two fractions multiplying, so we can multiply the two numerators and two denominators. 12 times root 15 is just 12 root 15. Root 15 times root 15, in that scenario, the roots cancel just to give us 15. So at that point, the fraction's been rationalised, but there's scope still to simplify it, and that's what the additional marks in the question are for. So we can notice here there's a common factor of 3 on the top and the bottom. So if we divide top and bottom by 3, we're going to get 4 times root 15 on the top, divided by 15 divided by 3, which is 5 on the bottom, and that's as far as that one will go. If you were to simplify the root 15, sometimes you can simplify the root part in a question like this, but you're just going to get root 5, root 3, and since they're both prime numbers and neither of them will actually square root, there's no point in doing that. That's not going to help us any. It just means we would have 2 roots there instead of 1. So that is the final form as far as we can really take the fraction in this case. In question 9, part A, we're asked to find the median and then the interquartile range. So notice that it's interquartile, not semi-interquartile, which is what they usually ask for. So slight change there in the formulas. Let's start by getting the median. The median is the midpoint of the set of numbers, so you need to put them in numerical order, which I've already done. Really easy to forget that. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So our median, our midpoint, will be between the first 5 and the last 5, so in other words right in here. So this here represents our midpoint, our median. So remember in quartiles that is Q2, but we also call that the median. So because that lies between two numbers, we need to work out what that midpoint would be. So either adding those together and dividing by 2, or just work it out by sort of logic. There's a gap there between those two numbers of 3. Half of that would be 1.5, and then adding that on or taking it away. So 38 plus 1.5 gives us 39.5. So the median in part A is 39.5. The interquartile range, the formula for that, remember, is not on the formula sheet. Interquartile range is Q3 minus Q1. If it was semi-interquartile range, it would be Q3 minus Q1 divided by 2. So Q3 is the midpoint of the upper set of data. So 1, 2, 3, 4, 5. So this would be the middle here. So that represents our Q3, 42. And then similarly over here, the 35 would represent the Q1. So just plugging in those numbers, we get 42 minus 35. So it gives us 7. So the 7 in this case, in the context of this question, is in years. So we'll just call that 7 years. So the context of this question is that these numbers represent the ages of readers of a magazine, and that answers part A. In part B, you've got a typical comparison question, and we're comparing these values to similar measurements for readers of a newspaper. So we want to compare basically the interquartile ranges, and we want to compare the medians. So in part B of the question, we're told that the interquartile range for the newspaper is 9 years, and the interquartile range we worked out in part A is 7 years. So those are the two we're comparing for the interquartile range. Similarly, for the median, we're told that for the newspaper, it's 41 years. And we worked out our median for the magazine to be 39.5 years. So to get the marks for these comparison questions, you've got to be slightly careful in the wording, making sure you get the key words in there. So first of all, comparing the two, let's go for the two medians first. Well, remember that median is a measure of average. So you need to get the word average or something that means average in there. So what does it tell us? It tells us that for the magazine, on average, the age of the readers is younger, smaller, or you could say that for the newspaper, the average age of the readers is greater or older. But the key is you've got to get the word average in there. Wouldn't matter which way around you compare those, as long as you get them the right way around and that you make the statement on average. To compare the IQRs, and again, you can word these in your own way, as long as you get the keywords in there. To compare the IQRs, the interquartile range, a similar sort of comparison, but remember that we're not measuring average like we were for median. Interquartile range, like standard deviation, measures consistency or spread. So what we could say here is that for the newspaper, which is this group here, because the number is higher, there's a greater spread or less consistent ages of the readers. Or you could put it the other way, and you could say that for the magazine, there, because it's a lower number than the 9, it's either a more consistent age of the readers or less spread of the age of the readers. In question 10, we're being asked to work out this width, and although a slightly complicated looking diagram, it does meet the criteria for a Pythagoras question, because you've got essentially a circle with a chord line, and circle and chord line pretty much always means Pythagoras. Why is it Pythagoras? It's Pythagoras because if you create a little construction line here between the center point and the chord line, that makes a right angle. So essentially you're going to be creating a right angle triangle. So in this question, they're telling us that this here, which is the radius of the circle, is 50 centimeters. And if you notice as well that the width that we're trying to find is also got a connection to the radius, because if we put a construction line on here, that would also be the radius, and that would also be 50 centimeters, because it doesn't matter where you draw the radius on a circle, it's always going to be the same. So that's part of the length that we want, the width. The other thing we need is to add on this part here. So that's the part where we're going to use Pythagoras, because that there makes a right angle. So essentially we've got this right angle triangle. I'm just going to pull that out to make it a little bit more obvious. And if we work with that triangle and work with the Pythagoras, then we should be able to get the solution that we're looking for. So this side here is 50 centimeters, that's the radius of the circle, so that's that part there. So it's going from point A to point C. We're also told in the question that A to B is 60 centimeters, so that's all the way down there, meaning that half of it, which is what we've got on this side of our triangle, is going to be 30 centimeters. So what we're trying to do in this question is to find out this missing side, and if we find that missing side, then we can add it to the 50 to get the total width. So just setting up your Pythagoras however you want. I suppose if this is point A, then technically this should down here be side small a, lowercase a. So it doesn't really matter about the other sides, but what does matter in Pythagoras, remember, is that the long side has to be on its own side of the equation. So the original equation, if you like, here would be that a squared plus the other short side, which is 30 squared, equals 50 squared. Or you could go straight to a rearranged form if you realize that it was one of the short sides you're trying to find, or just rearrange it at this point. So we get a squared equals 50 squared minus 30 squared. Keeping in mind that this is a non-calculator question, we expect that later on when we come and take the square root, we get an actual square rootable number. If it was a calculator question, it wouldn't matter because you could use a decimal number. So we're hoping that the numeracy works out well later on. Just keep that in mind. 50 squared, 50 times 50, that's like 5 times 5 with 2 zeros on the end. So that's going to be 25 with 2 zeros, so 2500, 2500. Same with the 30, 3 times 3 is 9, and then just put a couple of zeros on the end to give you 900. Keeping in mind that that's still a squared at this point. So going ahead to subtract these, that's going to give you 1600. And then we can get the a value by taking the square root of that number. So that's a little bit like taking the square root of 16, and then just keep in mind the zeros. Also keep in mind the context of the question. So this here and this here are the short sides of our triangle. This here is the long side, so the number we're looking for obviously has to be shorter than the long side and maybe similar-ish kind of dimension to the other short side. So square root of 16 would be 4, so in our case this side is going to be related to that 4, but it's not going to be 4 obviously, it's going to be 40. You could check that by then taking 40 and squaring it, which would be like 4 times 4 with 2 zeros on the end, which would give you 1600. So that tells us that that side there of our triangle is 40, and then the units for this question was centimeters. So going back to the actual question, that now tells us here that this part, so that's from here to here, is 40 centimeters, giving us a total width of 40 plus 50, and then just writing that somewhere in your working. So the total width is 40 plus 50, which equals 90, and the units for this question is centimeters. In question 11, we're told that the sine of 30 degrees is 0.5, and we're asked to work out the sine of 330 degrees. So you can either do this by a cast diagram or just by using the symmetry of the sine graph. Either method will give you the same answer. I'm going to go with the graph method. If you are doing the graph method, just be careful that your graph is accurate enough, or else it's going to kind of throw off your logic. So sine graph, remember, is the one that starts here at 0, 360 degree period, just like the cosine graph. So it's going to go something like this. So that end point is at 360 degrees. We're trying to work out the sine of 330 degrees. So 330 is going to be somewhere in about here. So 30 degrees back from 360. So what we're trying to work out, if you take a line down, so a little construction line down to where that meets the graph, and then sort of pull that back horizontally until you meet the y-axis, it's that value there, that y value that we're trying to work out in this question. That's what the sine of 330 means. So we're told that the sine of 30 is 0.5, so 30 degrees would be around here. So taking a similar method to what we did here, marking this on as 30 degrees, if we go up to the graph, so just drawn on a construction line, and then over to the y-axis, then they're telling us that that value there is 0.5. So if that value there is 0.5, just by the symmetry of the graph, basically the fact that this shaded area in here and this shaded area in here, or that length there and that length there are the same, that must mean that that vertical height, which gave us this number, let me make that a little bigger, 0.5, is going to be the same as that height there going down the way, so that value there has to be minus 0.5. So just by the symmetry of the graph, that tells us that the sine of 330 degrees is equal to minus 0.5. In this question, we're being asked to simplify using indices rules. So the denominator we can use the sort of multiply rule for. There's nothing we can do with the numerator for the time being. So we'll just leave that numerator as 5c to the minus 2. The multiply rule for indices tells us that if you're multiplying, you can add the powers together. So for 1 mark, you could add those to get c to the power of 7. We're now in a scenario where we can use the divide rule. The divide rule says to subtract the powers, so this is going to become 5c to the power of minus 2, so it's already starting off as a negative. Take away 7, so it's going to end up being negative 9. The question is asking us to write it with a positive power, so we need to flip this into a fraction to make it 5 over c to the power of positive 9. And that final move, which is another one of the indices rules going from there to there, that will give you the final mark, the third mark in that question. In question 13, we've been given this modified or transformed version of the cosine graph and a suggested formula for what this function actually is, and we've got to fill in the formula essentially to figure out the a and the b values. So this is really a game of spot the difference between this graph and a normal cosine graph. So just by looking at the graph, we can pick off what is different. First thing is that normally a cosine graph goes up to 1 and it's got a lowest point of minus 1. This graph's going up to 2 and it's got a lowest point of essentially 0 on the y-axis. So that means that the whole graph has been shifted up by 1. This b value, which is on the end of the expression, as opposed to the a value, which is in the bracket with the x, that b value changes the graph, moves the graph in the vertical direction. So just by inspection, we can quite easily, quite quickly, pick off the fact that the b value is equal to 1. The a value is arguably a little bit trickier. The graph does look a little awkward to interpret, but remembering that the midpoint, the lowest point on a cosine graph, occurs at 180 degrees. And you can see that in this graph, the 180 point is just a little bit to the left of that lowest point. Importantly in this question as well, we've got to figure out the increments that have been marked on the graph. So they're telling us at this point here at 90 is sort of 3 of those increments in. So that must mean that each of these increments represents 30 degrees. So the first one would be 30, and then 60, and then 90, and they carry on like that. So between this 180 point and this point, there's another one of those increments telling us that that point must be 180 plus 30, so 210 degrees. Still got to be careful with this because that means that the graph's been moved to the right by 30 degrees, but in this particular form, that works counterintuitively, meaning that instead of it being cosine bracket x plus 30, it's actually going to be x minus 30. So the a value itself has to be negative 30. So a little bit tricky that. A lot of students, I'm sure, will write in 30 there, think they've got it right, but that one works counterintuitively. Okay, so that's question 13. In question 14, we're trying to solve this inequation. A little bit fiddly because it's got fractions, multiple fractions with different denominators. Different ways to go about this. You could combine the fractions, you could make a common denominator, or get rid of the fractions one at a time, but ultimately you do have to get rid of the fractions. I think we'll just do this one at a time. So we can start by maybe getting rid of this one just by multiplying every term in the equation by, or the inequation by 3. So multiplying this term by 3, remember that just cancels the 3 on the denominator. You don't need to actually multiply the numerator, so it's just going to leave you with x plus 1, so that's been multiplied by 3 just to get to that point. You've got to multiply everything by 3, so that becomes minus 6. Multiplying that fraction on the right hand side by 3, remember you only want to multiply the top by 3, because if you multiply the top and the bottom by 3, it's still actually the same fraction. So this is just going to become 9x over 5. So that gets rid of one of the fractions. We want to go ahead and get rid of the other. So similarly, multiplying every term by 5. So this term here would become a 5x, then a plus 5. You could have combined these numbers first. I'm just going to go ahead and combine them on the next line. 6 times 5 is 30 to give us a minus 30. And be careful again not to multiply the 9 by 5, because multiplying this fraction by 5 will just cancel the denominator to leave you just with 9x. So remember the goal in these, like equations, are to get the x's on one side and the numbers on the other side of the inequation symbol. Before we work on that, let's just go ahead and tidy up our numbers. So 5 minus 30 is minus 25. Is greater than 9x. Doesn't really matter what side you put the x's on, but in these inequations, remember that if you end up with a negative coefficient on the x term and you're then dividing by that, you need to flip the symbol. So personally, I still prefer, even if it is a negative, to have the letters on the left and the numbers on the right. Most students are the same. So 5x minus 9x, by subtracting 9x from both sides is going to give minus 4x. Adding 25 to both sides, you can do that in the same line of working. We'd give the 25, positive 25 on the right hand side. So it comes out to be like that. And then we just need to divide both sides by negative 4. Slightly awkward in this case because 25 doesn't actually divide by negative 4. So we're just going to have to leave that as a fraction. Or you could use a decimal number, but probably a fraction is best in this case. Because we're dividing by a negative, we need to flip the symbol. If it was an equation, you wouldn't have to do that, but an inequation you do. So it's going to be x less than 25 divided by negative 4. That fraction won't simplify, so that's the final answer for question 14.